Yes, ma'am, I can hear you. Ma'am, can I start?
Yes,
Yes.
please.
My warm greetings to one and all present here, respected dignitaries, our beloved faculty, and my fellow friends. A very special morning to one and all. I'm Akshita from CSE AIML department. I'm so privileged to extend my warm welcome to everyone present here for this day 2 of this professional development program on applied artificial intelligence and expert system organized by Department of CSE AIML. Now, let me introduce the speaker for today. Dr. KP Suprati, ma'am, has an experience of 21 years in teaching and 12 years in research. She completed her Bachelor of Engineering in Computer Science and Engineering from Gulbarga University, Karnataka, MTech in Computer Science from JNTU College of Engineering, Anantapur, and PhD in Computer Science and Engineering from JNTU, Kakinada. She has attended over 38 international conferences and many national conferences and has published over 35 international and national journals. She is currently guiding 4 PG students projects and 8 PhD scholars and has guided around 50 PG projects and 35 UG projects. Dr. KP Suprati was co-principal investigator for UGC Major Research Program, a project on design, construction, and analysis of comprehensive data set for emotion detection using multiple biometrics worth 11 lakhs. She is a member of Doctoral Review Committee of Vellore Institute of Technology, Vellore, and has been awarded a patent. She is an academic coordinator and startup cell coordinator for JNTUH University College of Engineering, Hyderabad. Thank you, madam, for joining us today.
Thank you. Thank you for the introduction, Akshita. Okay, so now I want to share my screen. Hope that's visible to you. Hope it's visible.
Yes, madam, visible.
Okay, thank you. So, Padmaja madam, just brief me about the participants. Like, it's a mix.
Participants are both students and faculty, madam. Okay. So I have allowed my students because they have AI and expert system in this semester.
Okay.
5th semester. So students are also there, madam, and faculty members are also there.
Okay, okay, madam. Okay, thank you.
Yeah, kindly take a seat.
I'll take the session.
Thank you, madam.
Okay. So good morning, all the participants. I try to have little bit interactive session because when I tell online, people should not think it is one way. Okay. So let me first take some inputs from you. Like, how many of you have heard about this word? You can just raise your hands. So knowledge representation. No?
Madam, almost all are new to this topic.
Okay.
First time they are going to listen to this topic.
Okay. So at least the word knowledge you might have heard about, right? A lot of you. So can I expect anybody can you give what is the meaning of knowledge? This is a very quite familiar word. Right from schooling, you might be hearing about this word. And any inputs? Anybody, either chat or in the chat also you can respond.
Actually, it is a information which is collecting the videos, audios, and all. This is about the knowledge.
Is it like you meant to tell only collecting information is part of knowledge?
Not like that, but it's like a text, alphabets, numbers.
Okay. So let me just give you a little input. The freshers who have not heard about this word or don't have a concrete idea about this word, like you just say, normally we consider knowledge as awareness or familiarity gained by experience of a fact or a situation. So that is, we are going to have awareness and familiarity that we are going to gain by experience. So when you consider a knowledge, so usually we have You might be hearing about the phases. Knowledge is power, knowledge is divine. Many of you might have heard about it. So knowledge is considered to be a very important aspect, and especially in this generation, one has to acquire the knowledge and one has to know how to present their knowledge to the others. Okay, so this is very important. And when you consider about knowledge representation, the field knowledge representation is one of subfields of AI, and this is very much required in several domains of artificial intelligence. Okay, so when we think about knowledge, so here you could see the next slide, so which is very essential in decision making. And in everyday life also, we are having knowledge which is actionable. So it will decide or it will help us to take up some actions, or it will help us to make up some steps in order to achieve the required goal. So when you consider, so here you could observe in the diagram, we take the flow layout, left to right, we will move on, the arrows indicate. So we have actually data, which is nothing but raw facts from the real world. So just now some participant was mentioning, like she was mentioning, it's the numbers, images and all. Like,
Madam, sorry to interrupt. We are not able to see your screen.
Oh, you are not able to see the second slide?
Yeah, please share it again.
Okay. So I'll share the whole screen. So that
Yes, ma'am. Now we can see, madam.
Now are you able to see the second slide?
Yes,
okay. Okay. Decision making. So here you could see. So we are having the data from the real world, so which you might have studied different courses about data, database management and all. And we usually process the data, which we consider it as information. Information is processed data. But whatever the information we have, so we will apply the experience, or programmatically we will apply the different kinds of pattern recognition techniques, or some background knowledge authority we will apply, and from that we are deriving the knowledge which we want to make it as actionable, and that will help to make the decisions. And decision making is very essential aspect in every walk of life and in every application development, which has to showcase intelligence. So here, one thing what I want all of you to remember is decision making is essential, and for decision making, knowledge is very much essential or mandatory. So how do we have this knowledge? How do we acquire the knowledge? How do we store it in the program? How we represent it? And how our program will pick up the knowledge and how it is going to be converted into action. That will be very much important for any AI or any expert system application. Here, if you consider, these are the considered 4 important elements of information science. And I want all of you to just remember, so the whole, whatever applications you pick up or whatever the domain you pick up in computer science, we will be definitely requiring these 4 elements. So the first one is data. As I already mentioned, raw facts which we collect from the real world will be considered as data. And we are going to process them and we will generate information. Like when you want to generate information, you can just simply run few aggregate operators or few statistical operations and you can generate information. And after information, we have to apply correlations, associations and everything, and you are going to derive knowledge. And you might have studied different courses like database management system, management information systems, or information retrieval systems, and data mining. Like data mining majorly focuses on knowledge discovery from databases. Like you are going to collect data and you are going to process, you will have knowledge. And sometimes from the real world, you will gain some background knowledge, which we again represent in terms of concept hierarchies or graphs or conceptual graphs or notations. We have different representations. But ultimately what we want is, we want to apply this knowledge for problem solving, and that's what is intelligence. The ability of applying knowledge to solve real world problems is called as intelligence. But above intelligence, nowadays, we want our programs to display wisdom. So wisdom is you have to decide what should be the right thing for that situation. Okay, so we have a funny examples for this. Like now, let us consider we have a knowledge that we know laughing is very much essential or very good for our health. So we know that as a knowledge, but in what situations you should use it, or in what situations you should remember it and you should laugh in order to improve your health, make some wisdom. Like you cannot laugh everywhere, or you cannot just underline the fact that laughing is very important. So that is, wisdom is doing right things. Doing things right, till knowledge, doing things right is important, but doing right things is displayed by wisdom. And as we know, you may have knowledge, but you should also know where to use it, how to use it, and how to improve the performance, how to do appropriate decision-making abilities in your applications. All that comes under wisdom. So I want all of you to remember, doing things right, doing right things. That is, there is a difference. So normally when we write any program, normally in programming exercises or any, you take your lab exercises. So we write a program, so we have some input and we expect some output. And if you're getting that input and output, so that is called as, like, you have executable program and you got the specific output. So that is, you're doing things right. Like you want some output, you're getting it. But doing the right thing means for that situation, which is the right thing to do. It is not like you know a lot of things to be done. So which is the right thing you should select and you should decide, and based on that you should perform. Like when I tell you, so you have to program the system and the system should showcase that wisdom. So for all this, we definitely require proper inputs to the program, and program requires knowledge, and it cannot understand knowledge how we understand, because human brains are effortlessly doing all these tasks. So we don't know how exactly our brain processes, but you should understand, you should know how to feed your computer, in what format you should feed it, and how it is able to process it. Storing the data is one aspect, processing it is another aspect, and doing the right things at right situation is the next aspect. All these things one should keep in mind, that based on that, we have to focus more on knowledge representation. So now here, I just want to give you input. So you have to remember the significance of knowledge, but we are not stopping there. We have to move towards the tip of the pyramid, that is called as wisdom. Always now, everybody wants smart applications. So smart applications means they should showcase intelligence, and we also move a little bit ahead of, we want our programs to be wise like a human being. So keeping that in mind, so I will focus only on knowledge. You should be thorough in data representation models. You should be knowing about how information retrieval happens, and from that, how the knowledge should be gathered, and then how you are representing it. So all such things we will be focusing. So now I just want to discuss here. So what is the significance of knowledge in artificial intelligence? So here, if you see, as I mentioned, intelligence is the ability to acquire and apply knowledge and skills to solve real world problems. So for that, we definitely require knowledge. And okay, so now I'll ask you one question. Anybody, you can answer. Like, how will you decide a person is knowledgeable? Among your friends, or among your colleagues, or among your neighbors. So how can you identify somebody is knowledgeable? So is it based on the degrees they hold? How will you tell? Okay, like I ask you, do you have knowledge? How do you mention about it? How will you showcase that you have knowledge?
By asking some questions or something.
Yes. So
by applying in various scenarios.
Yes. So usually we will come to know when somebody is answering your questions, or they're able to solve problems in a very efficient manner, and they can be like, you can depend upon them for any type of difficulties. We consider such persons as knowledgeable, Majorly, when we consider knowledge, we always see problem solving is one aspect, and another one is majorly we focus on question answering system. This is very, very important. In our olden days also, you might have heard about the very ancient literature like Rajas, and you had Munis and all. Like you might have heard about Adi Shankara also. Like when they want to when they want to agree that somebody is knowledgeable, they used to have lot of discussions, and in that discussions they will be having lots of questions. So the question answering system is considered to be one of the methods of evaluating the knowledge. So here when you consider, we also focus initially when we teach artificial intelligence, we also focus on question answering system. Like I give a paragraph, like usually in schools also we do that. So we usually give a paragraph of text, and below that we give you some questions. You should read that paragraph, you should understand, and you should be able to answer those questions. So like this question answering system has attracted a lot of people, and based on that, you may have to know about the knowledge representation. And almost all of you, like all youngsters, are very comfortable in Quora. Like you might have used Quora.com. Like whatever question you get, so you go to Quora and you just post there, and definitely somebody or others will be responding to it. So that indicates that the person is having knowledge and they are answering. So similarly in expert system also, you will study about expert systems. So we also require here some kind of inference mechanisms. Like you'll have knowledge usually in the form of rules, and you have a program which takes these knowledge rules or production rules, and it keeps on applying it in order to drag some kind of solution to a problem. So that is again establishing knowledge base is important in expert system. All majority of the people will be comfortable in databases, but preparing a knowledge base is definitely a challenging task for the programmers. Then we always want autonomous systems where I want decision making. So other participant has answered knowledge as taking right decision at the right time. So that is decision making is considered as knowledge. So that is one thing. And then the last one is Web 3.0. Like how many of you have heard about it? So if I could observe a lot of participants are here, you can just raise your hands. How many of you heard about Web 3.0 or Semantic Web? Okay. A few of the students are raising their hands. So are you experiencing Semantic Web on the web now? Anybody? So semantics means normally we has it as a synonym as meaning. That is, we have to focus on the meaning rather than on the keywords. Like usually now, if you see Google search, it goes across the keyword-based searching, but it has to deal the meaning behind those words or meaning in that given sentence. So semantic web is majorly focusing on several applications which will focus on AI-based applications, or they have to be intelligent applications or smart applications. The semantic web has to work on, and a lot of research is happening, and we also have few search engines which are focusing on semantic web. So here again, we will have lots of concepts from artificial intelligence, and we are processing the data. So in all various these aspects, the knowledge and knowledge base is very much essential. So because of that, we are focusing more on knowledge representation, and we also offer knowledge representation and reasoning as one semester course at PG level. So here we will see role of knowledge in AI programs. So this is the same thing what I mentioned. So we first have to store the knowledge, that is, we have to define the search space and the criteria for determining solutions. And afterwards, we will also pick up the reasoning procedures, which will display about the heuristic knowledge. Okay, so now we will see about knowledge. Like I just want to give you a brief history of knowledge. So here actually when it comes to knowledge, so knowledge representation, these two words have been widely used, or these two words have provoked philosophical controversies in the 5th century BC by Socrates. So Socrates, as just now we have seen, he has considered knowledge as to be proved through the process of questioning. And he actually used relentless questioning to check knowledge of others in fundamental subjects. At that time, they used to consider fundamental subjects as truth, logic, philosophy, and all. Okay, so here Socrates has actually worked a lot on this knowledge and representations and all. But that time, so the people were not readily accepting his proposals or his knowledge, and that's why you might be knowing he was condemned to death by the church. Later on, Plato is actually the student of Socrates in the latest century. So he has taken up the same work what Socrates was actually being carried out, and he has recreated the dialectic process of questioning, and he has established the subject epistemology. Till today, people study it as a subject. So I also want you to make a note of this, and you just spend 5 to 10 minutes on Google. You will come to know about this subject, epistemology. The epistemology is the study of the nature of knowledge and its justifications. And that has considered to be a new subject, which was completely focusing on knowledge, nature of the knowledge. And later on, Plato's student, Aristotle. So, how many of you remember Aristotle? Do you know who is Aristotle? You might have heard about his name in history books. Okay, there's a raise of hand by 6681. Good. So he is the tutor of Alexander the Great. Okay, you might be studied in history. And actually, Aristotle has worked more on knowledge, and he has also lots of works, and he has contributed lots of words, terminology, what we are still using today. He is a person who has coined a lot of terms, and he is a person who has prepared lot of words still we use for knowledge. And actually, as you see, Aristotle, he shifted the emphasis from nature of knowledge to knowledge representation, and he has coined words, and lot of words are from Greek and Latin. So, and he is the first one who has prepared in encyclopedia. And later on, still today, like Aristotle has coined the words like category, species, all these words. And now we actually use ontology. So even in ontology, we have the same terminologies proposed by Aristotle. So here, one more thing what I want to mention is knowledge representation is important, and it is multidisciplinary subject. So that it has influence from various other subjects like philosophy, psychology, everything. But for computer science, AI program development, we consider this is based on the theories and techniques from 3 branches. One is logic. I think from the schedule, I could see you might have been taken session on predictive logic yesterday, predicate logic. So that is logic. Like we study logic as a separate subject. And after logic, we have another concept called as ontology. So ontology means you will have concept hierarchies, you will have one particular domain knowledge we represent in the form of an ontology. And we also have considered it as knowledge engineering. And then we go with computations. So logic, ontology, computation. These are the 3 different domains one should be mastering in order to go for knowledge representation. Okay. So this is about little background about knowledge. And later on, people had varied knowledge types, and they have categorized into 5 types. Different like domains, different rules. We pick up data, we process in different ways, and you come up with different kinds of knowledge. We categorize it into 5 different types of knowledge. First is declarative knowledge, and usually in initial days of learning, so people will be given declarative knowledge. That means they will be provided facts, objects, concepts. So we will be just giving the basic declarative statements. Okay. Then we have structural knowledge. Structural knowledge means we will be having establishing relationships between the concepts or objects. Like you don't study as object as an object, but we will establish the relationship between concepts or objects. So usually when you deal with, even in database courses also, we teach you about ER diagrams. So that can also be considered as a structural knowledge. So that means you are going to have different objects and we are establishing a relationship. So you might have seen, you will establish a binary relationship between entities, or you will also have a concept hierarchy, that is class hierarchies among the different entities. Like that, we will establish the structural relationship. Then we'll have this procedural knowledge. So procedural knowledge means we will inform what are the responsibilities of the objects and what kind of behavior they're having and how do they collaborate together to solve some problems. So the procedural knowledge representation, we can depend upon few diagrammatic representations, so such as unified modeling languages, so where we show the collaborations and all. So then we have meta knowledge. This is again important for programming. That is, we will have knowledge about knowledge. That is, we will store knowledge of all other types of knowledge. Then we'll have heuristic knowledge. So heuristic knowledge is knowledge provided by experts. And this usually keeps on varying or it keeps on increasing by iterations. Like very frequently, experts will keep on updating this particular knowledge. The knowledge is usually of all these types. So now here, if you consider representing declarative knowledge is easy, the complexity keeps on increasing. Hello?
Yes, ma'am.
Yes, madam. Okay. So next we will see the knowledge representation and reasoning. So here, till now I just told you, we focus on representation. Representation alone is not sufficient. We should also use this knowledge to apply in different domains. So here we have this diagram, so which indicates this is from artificial intelligence. So here we'll have perception, and through perception we perform learning. Again, we can have different approaches for learning. And through their learning, they will be knowing how to represent the knowledge, what they have learned. Okay, so then we are using these representations to perform reasoning. And this reasoning knowledge or reasoning approaches will help us in performing planning or executing, such as decision making or question answering system, all that. So this is what is the space where you have knowledge representation and reasoning. So you require this when you go for learning approaches, and you also go for planning systems, decision making, everywhere. So, but right now, what is actually happening is, I am observing a lot of students from past 3-4 years. So all of the students are actually very eager to do projects in deep learning. When they are doing in deep learning, so it's almost like a black box. So they're not focusing how exactly they're storing the knowledge or how the data is being collected, how you are going to define the patterns, or how your system is learning. So we are actually taking it as a complete black box. We just give input, we feed some data set, and you just see the output. So students are not focusing how exactly the processing is happening. So this is the reason they are doing a lot of ML or DL programs, but they're not knowing about knowledge representation, but they're not knowing how exactly the reasoning is happening. But this is essential because we cannot have a black box approach everywhere. You should get deep knowledge, or you should get into your program and you should understand how it's exactly. So here, that's why we need mappings. Like we collect facts from the real world and you need to map it into representation. So you may have to represent appropriately, and after you have them in a perfect mapping or representation, so you usually have the reasoning programs. So the reasoning programs will go through the different knowledge and they usually generate new facts. So the new facts will be very much required for the decision making or question answering system. And these new facts will be again usually will be in the representation form, knowledge representation, what we are doing inside mapping, but they will ultimately will be converted back into English. They will also take up the English representation. So here when it comes, we usually have the knowledge level and the symbol level. So the knowledge level means which usually we are collecting from the real world. And the symbol level means we represent that knowledge in different representations. That is the internal mapping we pick up. And when you are answering the fact, so you should convert it back into the knowledge level. So this is very important. And based on that, based on the properties of knowledge representation, so we want these 4 properties. So that is, we want representational adequacy, inferential adequacy, inferential efficiency, acquisitional efficiency. That means whenever you want to prepare a knowledge representation system, so you should keep these things in mind. Representational adequacy means you should have the appropriate representation for all sorts of facts, for all kinds of knowledge, what you require for that domain. That is representational adequacy. Inferential means, as the name suggests, it should help us to drag inference, and it should have the ability of manipulating the structures what you are having, the mapping structures, whatever you are having, such a way that you will be able to drag new structures or the new mapping structures. And those new mapping structures will be converted back to new facts. Okay, that is inferential adequacy. Then we have inferential efficiency. So inferential efficiency means, so you have to need to have knowledge structures. They may have additional information that will focus on the new inference mechanisms. So that is inferential efficiency. Then we'll have acquisitional efficiency. That means it should have the efficiency to acquire new facts. It will generate new facts as well as it will collect from the experts, like as we have seen heuristical knowledge, which is given by the experts. The representation system should have all these 4 properties. Like when we want to think about representation, right now actually different researchers have proposed different representation mechanisms, representation approaches. Some of them may not be having all the 4 properties. So some will be very good in first 2 and they may not be very good in the last one. So like that, people have proposed different approaches, and still the research is going on, and still you can also have different kinds of representation subsystems, which will have the support for reasoning as well, because they need to have inferential adequacy. So now we will see 2 approaches to knowledge representation. So one of this you have already studied, but I'll just give you a brief overview about all that. So we have different approaches for knowledge representation. Very simple approach is relational knowledge. That is what we are widely using, databases, the relational database. So there you can observe we have entities, that is we focus on objects data, we group it them and we will have it as an entity set. And we will also have a relationship among them. Okay, that is structural knowledge. Declarative knowledge, you have a table for an entity set. Structural knowledge, you will establish the relationship between different objects. That is, you will have tables for relationship sets. The table for relationship set will have usually the primary keys of the participating entity sets. So like when you see here in the relational databases, people were handling facts, and in that they were actually considering it as declarative knowledge and little bit of structural knowledge, but it could not focus more on procedural knowledge. But when you want to come up with intelligent applications, so you definitely require even procedural knowledge. So for that actually, so people have gone for the next types of knowledge representation, that is you can pick up it as a logic. Okay, so if you consider logic is again a very big topic, and many number of times. Okay, so let me just hear from you. So what do you mean by logic? What comes to your mind when you hear the word logic?
Sequential steps to solve a problem.
So is it the steps to solve a problem? Okay. Any other answers?
Applying a set of rules.
It's applying set of rules. Okay. So you are giving the answer pertaining to our computer science background. So we'll have logic even in maths, right? Actually, here logic means we usually have reasoning, and there you definitely need to have some principles of validity. Okay, and many number of times in the world, so we the Indians and the South Pacific region, so people appreciate a lot because we are having a lot of logical ones. Like you might be knowing, like you will be given some problems and identify what comes next in the sequence. Like you'll have a number series or some ciphertext. So you will have different things, and you will be able to identify quickly what comes next, because you will understand or you try to predict what is the model people are following in it, and you will apply that model and you are going to solve that particular problem. So when it comes here, there is a validity. Like now let us consider I give a number like 1 4, okay, 1 comma 4 comma 9 comma, like I give 16 comma dash. Like immediately you will tell, like I have a number series 1 4 9 16. What comes next?
25.
So how you are able to tell 25? Because you like we people will very quickly identify. So how you could tell is you have processed the stream and you would try to find what is the relationship you are having for n to n minus 1 or n to n minus 1 n minus 2, like that, and you will build up a model, and from there you are going to apply the same model to the next coming number and you will be able to tell it. So this is very important, and many number of times we can like need to understand the logic, especially people who want to excel in programming. You should know the logic. So in one way, what I can tell is, if we can understand or validate how you think, so it becomes very easy for us to understand the logic. And this is a very important domain, and logic is considered to be very complex subject, so people usually study, and we have lots of things to be learned. Like for knowledge representation, we usually have first order logic, the propositional logic and first order logic. So maybe yesterday's class you might have studied about that first order logic. So how you represent English sentences in one particular rule format. And then how do you apply these rules in resolution, and how you can answer a question, or how you can generate new fact, or we can also observe what is missing knowledge also. All that we usually have it in logic. Then we'll also have inheritable knowledge. The inheritable knowledge means we usually identify the relationship between like you see easier kind of relationship or parent-child relationship. So we also know inheritance is a topic we teach you in object orientation. We always want to know how properties of a parent is inherited or is passed to child. So here knowledge also we want to represent in the inheritable way. Then comes ontology. The ontology is also a well-established domain. So we are having different languages also. We can call them as OWL. Okay, so that is web ontology languages. We consider it as OWL, and we have different categories of OWL, like OWL Lite, OWL Descriptive Logic, and we also have OWL Full. So using these languages, so one can develop ontology. A lot of researchers have spent their time and effort in constructing ontologies for each domain. Okay, and all these things help us in knowledge representation. And ontology will also help the programmers computation in order to derive new knowledge. So this is relational. So where you can observe we are having this table format. So table format, if you consider, you are quite familiar with this representation, and usually we deal lots of times data in the form of tables. But we have seen some drawbacks, like handling procedural knowledge becomes a challenge for us. Then we have logic. So in logic, as I already mentioned, we will have three components. In that, semantics. Semantics means we have to link to the world. If you're collecting the facts from the real world, you have a representation within that. The semantics means you should link back to the world. And we'll also have the proof theory. So in proof theory, we usually will be pushing the symbols and we apply some algorithms like unification or resolution and all. And in logic, we study two types, propositional logic and predicate. So this is what is the logical representation. So you can observe here. So you're having this. So this diagram I have taken from AI textbook. Okay, written nice. Citation I forgot in the slide. So this is from written night. You can observe here. There is a world. So that is you collecting facts from the world. And these facts are representing in knowledge representation, maybe as the sentences or any other rules or something. And those sentences are entailed. So we apply inferences and we apply resolutions, unification, what all the algorithms we have, we do is, and we may be generating new sentences. And those sentence semantics will be converted into facts, which are again represented in an understandable format called as words. So here you could observe one fact which I'm representing as a sentence. If it entails new sentence, definitely the new fact will follow the old fact. So this is what is the logical representation. So this is how we focus on knowledge representation in the form of the representation approaches. So here propositional logic, hope you might have studied this in your earlier UG courses like discrete mathematics or mathematical foundation. So syntax is we build sentences from atomic propositions using different connectivity, and you might have studied it as different truth tables, and you will also go for validities and inferences. We apply different rules. Okay, you might have studied about modus ponens rule, modus tollens rule. So like that, we apply those rules and we will be generating or grabbing new inferences. So then proof theory means usually we will have this. So we have syntactic rules. They are derived from the logical consequences of set of sentences. So if there is a new rule alpha or a new fact alpha which is deduced from by the knowledge base, then definitely alpha is provable from knowledge base. So we consider all the rules as knowledge base, and the new rules once again add back to the knowledge base. And here, both in propositional logic and first order logic, that is logic, so we will have the proof theory. We are using the calculus. So here we form them as entailments. So we usually do that. So I hope these are all the different logical sequences we have, and you might have studied about all this in predicate logic. I just skip it. So in predicate logic, this is little advantages that if you consider, you can make sentences about objects, and you can also focus on properties of objects and relationship between objects. So here again, we are establishing the declarative and structural knowledge, but still it is difficult to have procedural knowledge. So the behavior of the knowledge cannot be represented here. Okay. So propositional logic cannot establish or represent relationship between objects, whereas predicate logic can do it. Okay. So here, actually, I have taken different examples, but I'll skip this because you have already studied about predicate logic. Okay, so I assume it. So these are all the different expressions in the predicate. Then we go for inferencing. Like in calculus, propositional logic or predicate logic. So we have inference mechanism. So that's where we do this resolution, forward chaining and backward chaining. So now whenever I want to prove anything, so I usually take from, like when you take from the initial state to goal state, if you move, we consider it as forward chaining. If you are moving back, like you want some output and you are backtracking from the output to the input, we consider it as backward chaining. And resolution is usually I want to, for question answering systems, I go for resolution. Like I take a sentence. Usually I negate the sentence. I negate the sentence and I try to observe a sentence or a rule which is there in the knowledge base, which is going to contradict with it. So that is, I am considering something from the knowledge base, and if it contradicts, so we are left with empty notations. Like you will cancel off all the negations. It is like P and not P. Like if you consider there is one representation P and there is another representation P. So both are contradictory, so they will be resolved and you will be left with an empty set. So that is what we do in resolution. This is inference mechanism. Until today, we are going for forward chaining or backward chaining, and some authors also, like some researchers, have also proposed to retain the advantages of both forward and backward. So we proposed a hybrid approach incorporating both forward and backward. So this is an example. Like I'll skip this. I hope you might have studied this in predicate logic. So a set of sentences will be given, a question will be asked, and you should prove that the person is, that particular question is yes or no. So this is what we do in predicate logic. Then we focus on slot and filler structures. So here we want to focus also on procedural knowledge, along with not just structural knowledge, declarative and structural, we also want procedural. So in AI research or AI literature, so we are having different knowledge representations. We are categorizing them into weak and strong. So weak slot and filler structures and strong slot and filler structures. So here we will pick up the different concepts. Like you could pick up, we are having the semantic nets, frames. Semantic nets and frames are considered to be weak slot and filler structures because they may not be focusing more on procedural knowledge. They focus on the structure. The scripts, conceptual dependencies, and we will also have the CYC representation. So all these things are considered to be strong slot and filler structures. This is very complicated knowledge representation, but at the same time, they have all sorts of support for decision making or question answering. So I'll take you through these different structures. Okay, so first we will pick up the semantic nets. So here if you see, we are focusing on meaning of the concept based on connections with other concepts. And in semantic nets, we can also handle inheritable knowledge or inheritance knowledge using easier relation and instance relation. Instance relation is like object is an instance of a class. And one object is another object. That means it is a parent, it is a child, you can mention it in that. And we can also perform intersection search. Like if you have two different concepts, you can still establish a searching by having an intersection of those two domains. And here semantic nets are proved to be good when I'm dealing with non-binary predicates. That means when I have more number of concepts involvement in any one particular, more objects are involved in one concept, so we can easily represent in semantic. So here we will take an example. So this you can observe. So you're having representation which may look similar to your class diagrams, like the rectangles indicate the objects or classes, and we will establish the connectivity. Okay. So now just you go through this slide. The slide indicates snow versus ice. Now, if I ask you what is the difference between snow and ice, you take some 1 minute time and just read it. So here now, this is the fact I have given. I have represented in this way. You can observe an object is having a property. It is having some value. Okay. So on the edges, you are representing the property name. So now when I ask, so tell me the difference between snow and ice. What is the difference? Anybody? The mathematical formula to apply. Okay. Any other answer? I expect youngsters, like in students, you can give very quickly the answer, I suppose. So, how many properties are common? So, is temperature having same value?
Yes, temperature, form of,
So, form of is also having same value. Temperature is having same
Texture.
value. Texture is also having same value. So, when I ask difference, you should identify things like value, like hardness. If you see, snow hardness is soft, whereas ice hardness is hard. Okay, and color also you can pick up. So snow is having white, whereas ice is having colorless. Okay, so here if you consider, we represent some knowledge in the form of semantic nets, where we have objects and we will have the properties, and the properties values also we represent as in the form of rectangles. So similarly here we are having the different aspects, like hierarchies also can be represented. So when you consider here, you might have studied this sort of representations when you have been taught about object-oriented programming. So we mentioned, so here you could see, bird is, like canary is a bird. That means canary is a specialization of a bird. And these things are usually represented in the form of hierarchies. And here you could see, as the complexity of the sentence increases, the time to answer a question is also increases. So now if you are having an hierarchy like this, you can observe this is considered as a root of the tree. And from here you have a bird and fish as the children, and bird once again having two types, canary and ostrich. So canary can sing, ostrich cannot fly. So then I may ask, is canary an animal? So then you may have to start from canary, and you usually come up with like this here. So canary is a canary. Canary is a bird. Canary is an animal. Because bird is an animal, you will replace bird with canary. So like this, we usually have this representation. So here, if you consider nowadays, lot of people are working on this question answering system using speech, because many of us are very much excited to use Alexa and all, Siri and all. So people are able to do this simple projects. Students are able to do simple projects by taking APIs which have been developed by somebody else. But internally, how the data is being processed and how actually the inferences are being handled, so one has to know about it. So this is one way how we are going to have the hierarchy. So when you have a more hierarchy, definitely it takes more time to process. So here you can observe we are having binary relation, so where you are having bird flies. That means bird can fly. This is binary relation. Similarly, we can also have a binary relation. That is, you can observe dog is having a color and its value is brown. So that means if I have a brown dog, I have to represent it in this form as a semantic net. So then we'll also have sometimes a theory relationship or ternary relationship. Child is having parents and parents will be father and mother. Like this, we'll have different domain knowledge and there will be a lot of options for storing semantic nets. So here you could observe that a sentence is simple. The dog named Emma is brown in color. Okay, so otherwise I can have a brown dog name is Emma. Like I can have such color description of a sentence. But when I want to represent the knowledge, I usually have like this a complication. So I will be having some unique identification for the dog, and I'll mention its name is Emma and color is brown. Like this, we have to go with semantic nets. So here you can see more behavioral aspects also, but when you want to mention about the procedural knowledge, it takes more complication. So here you could observe the dog scratches its ear, we are mentioning. So here, a dog, we have some identity for it, and it is scratching. So for scratching it, so who is scratching? The agent dog is scratching. What is the instrument? The paw. So which part is scratching here? Like this, we need to have a complex representation. Like you will be having different notation for the actions and instruments. Then what is the verb, like their performance. So this is how we are having different semantic net representation. So then we will have frames. The frames was also quite good up to some level. Like this, I have taken again from Luger textbook from artificial intelligence. So here you could see frames. You will actually mention the brief description about it, or the knowledge is represented. Mostly we are focusing on declarative knowledge. So here you could see. So we have a description about a hotel room. What all the things that hotel room contains. And for each item, we may have a further description, like when I tell a hotel chair. So what will be the height, how many legs it is having, what is the purpose of usage, like this. We may be having for each description, we will be having several different frames. So, but listing everything according to our domain expertise, so it takes a lot of effort. So this is about frames. But both frames and semantic nets are considered to be weak slot and filler structure. So we go for scripts. So script is considered to be good, but if you consider, it describes a stereotype sequence of events in a particular context. And scripts should have all these important components. We'll have entry conditions, we will have props, we will have roles, tracks, scenes, all these things. It's almost like you will be preparing a script. Usually you will hear this word in movie making. They'll have a storyline, but for that storyline, they will prepare the detailed scripts. So the same thing we also do here, but imagining all the sequence of events and preparing scripts for all the scenes is definitely time consuming and hectic. So this is one example, which again I have taken it from the Chennai textbook. So you could see here the script is restaurant, the track is coffee shop, and we have props, tables and menu, food, we'll have check, money, all that. And we'll also have different roles. We'll have customer, waiter, cook, cashier, owner. And using these words like S, W, T, everything, we are going to have some kind of activities. So when you consider, so you can observe here, we have few words or a few predicates like P trans, M trans. So P trans means it's like a physical transforms, or a person is moving from one place to other place, we consider it as P trans. So there you could observe the customer will P trans to restaurant. And again, so a customer will P trans to a table. Within the restaurant, he will go to a table, like that. Every step you may have to register. But this takes a lot of time and effort. But scripts are considered to be good when people were able to handle the reasoning or able to make question answering systems. Then we have the other thing called as conceptual dependency. And conceptual dependency is considered to be very efficient, but the internal representation is quite complex. The people who are collecting the knowledge and who want to represent the knowledge using these representational structure needs training. So here, if you consider, we are having lots of actions. Like you could observe here, we will have actions, we will have objects. Like objects, we are considering it as picture producers. And we'll also have modifiers of actions, that is action aiders. And we'll also have modifiers of objects. These are the representations we have. PP, AAPA. And in our representation approach, so we need to use the same terminology. We have to follow. So here again, we are having the sets of actions that are actually being followed by the objects involved in the domain. So A trans is transfer a relationship. That is, you want to give or do something. This indicates what is the behavior the person is doing, what is the action the person is doing. It's not only focuses on declarative knowledge and structural knowledge, but it majorly focuses on procedural knowledge, like what kind of behavior they are having, what kind of interactions they are having. So here you could observe P trans is transfer physical location of an object. So propel, move, grasp, ingest, expel. These are the standard predicates they have declared for conceptual dependency, and we are supposed to use the same things to represent a sentence. And afterwards, they are following different representations. So here you could observe. So PP double arrow act, that indicates that an actor acts. So PP, so double arrow PA, that indicates that an object has a certain attribute. So we will have all these kinds of scenarios. So here you could observe a person is donating an object to another person with some action. Then we use this notation. Okay, so like this, we have a set of notations which we are using in conceptual dependency. So like this. So here, I think you can see this slide. The rightmost column is English sentence. For that, we are having this. These are considered to be the structures which we are going to follow. And these templates we are following, that we are applying, and we are writing the equivalent conceptual dependency representation for the sentence. Okay. So here you can just observe a few sentences. Like we mentioned, John ran. That means John has performed P trans. So, and again here, when I tell P, it is past tense. And I don't mention anything that is present tense. John runs. If I don't have P there, it becomes John run. When I tell P, it becomes John ran. So like that, we have different notations. So here you could observe John pushed the cart. So that means cart is an object which is being propelled by John and pushed. Okay, so that indicates it is past tense. And here, similarly, we can mention the plants grew. The plants grew means there is some particular action which is being taken, and you usually have a change in their stage. So that we are representing here. So initially, if plants are being grown, the initial stage is size is X. So after that, size has been increased. Like this, we are having the different representations in conceptual dependency. So here, when you think about, so you will have a specific method, and in that we will have specific parameters, and we are going to pass those parameters. Like you can imagine these things as your templates, okay, which declares your methods, and you may have to pass parameters for these methods. Based on that, you will be representing different sentences, and all these sentences will go into knowledge base. So here you see there is a simple sentence. So here if you consider, so John ate an egg. That sentence represents to this much representation. Okay. So similarly here if you see, so we are having, so there is a recipient, like Mary has taken something from the bill. So bill becomes the receiver. Mary is giving a book to the bill, but John don't want Mary to give a book. Like this, as the sentence gets complicated, the representation also gets complicated. Then we have this CYC project, and this is a very lengthy, long-term artificial intelligence project, and I want you to explore about this project, CYC project by CYC Corporation. So here you can see they have actually done a lot of surveys, and they have done rigorous research. And from 1984, the project is on, and they are still focusing on the different knowledge representation systems. And their motivation was they wanted to have knowledge littleness, and they also wanted to have shared knowledge. They want to share the knowledge, and they want to build an immense knowledge base, so which usually will support machine learning as well as natural language understanding. And again, natural language understanding is a very uh, big challenge that we are having with the artificial intelligence application. So these were the motivations for this UIC project, and they have done a lot of research. And the recent release was in 2017, but still the research is going on. They are focusing on how to span the basic concepts and tools and how the world works. Okay, so this is we are having about the CYC. So here you can observe we are having this CYCL frame-based language. So they have taken the concept of frames and they wanted to actually extend the knowledge. They want to go with the frame-based languages. And along with that, they also wanted to have the support for control and meta languages. So meta knowledge means, as we have seen, knowledge about any other types of knowledge will be considered as meta knowledge. And control knowledge means when we are applying inference mechanisms, so we need to control the flow of the rules. For that also they require an additional knowledge called as control knowledge. And CYC is focusing more on proposing a global ontology. The global ontology means which will be familiar with various different kinds of domains. Okay, so now let me just ask you a question. So what is Kiwi? Any answer on chat? What is Kiwi? Nobody? The 6669? So only Nagaraj sir is answering. So thank you, sir, for your interaction. So, nobody heard about this word?
It's a bird and fruit line.
Bird and fruit. So you tell both. So when you consider that word, like depending upon, like if I tell kiwi is good for health, so you will understand it as a fruit. So what I mean to tell you is, usually we have some words specific to one domain, but some words are appearing in multiple domains. Okay, so let me just ask you. So how many of you have heard about this? So in the chat, I'm giving the word. How many of you have heard about Wordnet? Anybody? I expect the faculty members. At least you browse Google now and tell me what is Wordnet. No, no one heard about it. If you not heard about it, make a note of it and try to explore about it. Okay. I could see lots of people responding. I think you can unmute yourself. Okay. Okay. So good. Muhammad has given database of English words. Okay, database of words. It's actually Wordnet is a lexical database. It actually handles English words as you mentioned, but it considers lots of things. It describes the semantic relationship between words. you could see, you'll find homonyms, you will have hierarchy of relationships and all. So why I'm telling you this is, so Wordnet has focused about English words, but ontology focuses on one particular domain. Like when I'm preparing something about nutrition domain, so I will have kiwi there. I have to understand it as a fruit. That means I need to have a context-based understanding of the words, because you will have synonyms, you will have antonyms, you will have polygons, like you will have different terms of words in English. But when it comes to the CYB project, we have ontologies, as I earlier mentioned, we have ontologies for different domains. Like education domain, I have an ontology. For healthcare domain, I have one ontology. Insurance, I have one ontology. Like that, I have different ontologies. But they are in need of having a global ontology. Like if you consider, we know about a lot of words, we know a lot of knowledge, but based on the context, what I'm asking, or based on the platform where we are interacting, so we pick the meaning from the appropriate domain knowledge. So like when I tell kiwi, if I'm speaking about nutrition, kiwi means you will understand it as a fruit. So, but people wanted to have a system to have a global ontology, which is a very challenging task. And you should also establish the relationships across the ontologies, that is cross-domain ontology. So still people are finding it very difficult, and they're spending a lot of time to come up with global ontology. So you may have to consider yourself in such a way that using the existing support, you can also think about picking up an ontology which covers different domains. Okay. So, and in that again, you take ontology as a knowledge base and you are running a question answering system. It has to take help of the ontology and prepare your own inference driving mechanisms. Okay. So these are all the slot filler structures which are considered to be very strong. Scripts, conceptual dependencies, then CYC. CYC is again using a language which is a frame-based language. And still, till today, a lot of research is happening on this CYC representation. So these are all different kinds of knowledge representation. So these are the different references I have used. And the first book is giving lots of information about knowledge representation. They are actually going with the concepts of philosophy, logic, and all that. So all knowledge representations have been covered in that textbook. Okay. So if you have any doubts, I'm open for doubts. You can have the discussion. Anybody? So I just want to hear, is anybody interested to do research in AI from the participants, or anybody doing research? And usually my advice for the researchers is to don't just think AI is real, deep learning. Lots of people are just looking on deep learning, and thanks to Python and thanks to tools which are giving you lots of support, they are giving you like a black box. Okay. Without knowing anything, people are using different kinds of deep learning techniques. They're processing images, they're processing videos, but they don't know how exactly what features they're picking, what kind of knowledge is being stored, and how when a new sample comes, how the patterns have to be formed or patterns have to be matched. So people are actually not focusing on that low level details. Okay, so this particular course, like knowledge representation and reasoning, is very much essential to whatever application you pick up. Okay, so any questions?
Madam, knowledge representation should be considered as the first step before doing any kind of AI programming.
Yes, madam. We should first understand what kind of knowledge you are going to store. So you will decide, and then you have to think about appropriate representation system.
Can you exactly tell, is it having any relationship between natural language understanding?
Natural language understanding also requires knowledge representation. Like now, if you want your system to understand new sentences, so it has to usually be fed with the basic domain knowledge that you require in knowledge representation. And when a new sentence is being given, it has to learn or understand by applying some kinds of inferences. Like as I told you, like we take some facts, we represent in some rule formats or some representation like frames or scripts. From those scripts, you may derive a new sentence. That is a new phrase. From that new frame, you will be generating a new fact which will be meaningful to the real world. So that knowledge map, representation mapping is also required. But right now, what people are doing is, now let us consider we are feeding lots of videos to a DL program. Okay, so people are doing like they want to detect the presence of a weapon in a video or an image. So what they are doing is lots of weapon images are being fed to your program. Okay, madam. Like
Yes.
you are having a CNN or you are having a neural network where you will feed images which has different kinds of weapons. That means it is getting storing the shape of the weapon or the color of the weapon and everything. And when a new image is fed, it is going to detect that. So it's going to show, like if it is not identifying the weapon, you give training with more number of images. But how it is going to store that knowledge, and when a new image is coming, how it is making a check, so people are not knowing exactly. So when you tell, the students usually will tell the presence of a weapon. So how does the program comes to know whether there is a weapon or not? Because internally, physical level details, they are going to store everything in the memory in the terms of pixel values. So how exactly that representation happens means, so for everything, it has to get trained, because when you are training it, you will indicate first image, there is a weapon. So the image it will store and it is going to represent the values in the form of a feature vector, and that they are going to process. That's one thing. When it comes to natural language, so the sentence, when it is getting fed, that sentence is not stored as it is. Usually people are going with embedded networks, the word embeddings. So all that is happening, but we are having a lot of built-in methods. We are using built-in methods. The students are not looking inside what is happening in the built-in methods. So the knowledge representation is happening inside those built-in methods.
Last question, madam. Is there any specific tool for knowledge representation?
No, we are not having specific tools for knowledge representation. When you are going for machine learning approaches, according to your domain, we may have to come up with existing ontologies if you are dealing with natural language processing. Okay. So I told you Wordnet. So these are a standard support what we are having for knowledge. You can consider them as lexical databases or support you can get from knowledge bases.
So ontology-based representations are a kind of
used.
knowledge representation only.
Yes, madam.
Okay, thank you so much.
And logic is also very much required.
Any other questions, participants?
Is knowledge representation and generating set of rules stage. So set of rule generation from the real world comes under knowledge representation. There's a question from Nagasir.
So finally, it needs to be represented again in if else rule form.
It depends, madam. If it is like when we tell, like you are going with logical representation, so then you'll have if then else. If you want to store it in a semantic nets, now actually we are having this augmentation networks also. Okay, so if you want to store in that network format, the format is different. You will not have rules there, like as we have seen semantic nets. So one sentence we just store. You might have heard about dictionaries, key value pairs.
Yes.
Something like that also you can store.
Okay, thank you.
Declarative knowledge. Okay, madam. Thank you.
Any other queries, participants? Students?
Okay, madam.
Thank you so much, madam, for your
Thank you.
valuable time and a wonderful presentation on the knowledge representation. I'm very
Okay.
highly thankful to you. Thank you so much.
Thank you. Thank you.
Participants, dear participants, the second session on knowledge representation is cancelled due to some unavoidable reasons. And afternoon, Professor Atul Negi's session will be as usual from 2 to 4 p.m. Kindly join at 1:45 p.m. Thank you so much.